All right, what we're going to do on this video is specifically talk about completing the square for different types of conics. So you're going to see is I'm going to do an example for each conic, starting with the circle, then the ellipse, then the hyperbola, then the parabola. And then the second one will be one that what I'll have you do is try it on your own. And what you'll be able to do is I'll tell you when to pause the video so you can work on it, and then restart the video to see where that next step should take you. So one of the things you may want to do is, if you're looking at this for circles, is write down the time that we finish so that when you need to look at the ellipse piece, you know where that one starts. That might help you too. So, but again, with our circles, when we talk about completing the square, what we want to do is take something that's in general form and get it into standard form so I can pull out my center, pull out my radius, and then be able to graph it. So step number one, again, what I like to always do is follow similar steps all the way through, is get all my x stuff together. Okay, so I'm going to put the 3x squared and the 6x together. Put my y stuff together, so the 3y squared, the 12y. And I like to put the constant over on the other side because, again, remember, eventually you're going to have your radius squared on that side. Second step, what I need to do is get my quadratic coefficients to be equal to 1. Now with circles, again, a is equal to c. Okay, because again, our general form, ax squared plus bxy plus cy squared plus dx, ey, and f equal to 0. Okay, we always are looking at a and c to see what's going on. Since they're the same, all I really need to do is divide by whatever a and c are. And I got to make sure I remember to divide it into every term in the equation. That will get my x squared to have a coefficient of 1 as well as my y squared. And again, it's very important you remember to do it to the constant as well. That's sometimes forgotten. Now, the next step, and that's one that can cause trouble for some people. What I want to do is take half my linear term. Linear, again, is anything to the first power. So x to the first, y to the first. I want to take that coefficient. So in this case, 2. Over here with the y, it's the 4. What I want to do is take half of that. Okay, so I'm going to take half. And then what I want to do to that is square it. Okay, so I'm going to square the 1, and I'm going to square the 2. Now, what I'm going to do is I'm going to add that to both sides of my equation. So when I added the 1 to the x stuff, I also have to balance my equation, add the 1 to the y, or to the right side. When I add the 2 to the y stuff, I also need to add the 2 to the other side. Okay. Now, the piece that sometimes we struggle with is what I want to do is rewrite these as binomial squares, because again, remember, I need x minus h squared plus y minus k squared. Okay, I don't need x squared plus 2x plus 1. Now, here's your x. Here's a couple things that are going to happen. That linear sign is going to come with what we took, or when we took half that linear expression, that's going to be the piece that goes with your variable. So sometimes people talk about bringing the sign with, sometimes people won't. You can look at it either way. Okay, if I took half of a positive 2, it's a positive 1. Okay, if I take half of positive 4, it's a positive 2. But now I have my equation in a standard form. Now, one of the pieces that people will still struggle with is they say, well, what happened to a couple of things here? What happened to my 2? What happened, to the squared piece? Remember, those two things are the same. X plus 1 squared is the same as x plus 1 times itself, which when you multiply that together, gives you x squared plus 2x plus 1. What we're doing is we're just putting it in a different form so that what I'm able to do is have it as that binomial squared and pull out my center. Okay, so don't get so worked up about that. But here's our final situation. We now have it in standard form. We can graph it. All right, so here's the second one we're going to look at. Okay, what I want you to do, like I said, is I'm going to have you go step by step with this one. Okay, so write it down, pause the video, okay, do the first step, start the video up again, and see if you're doing it correctly. All right, so I put my x stuff together, x squared minus 8x, put my y stuff together, y squared plus 6y, put the constant over on the other side. Okay, so it became a negative. Again, pause, do the next step. All right, second step, quadratic coefficients being equal to 1. They already are. So really I was able to just skip that step and now move on to step 3. Again, pause. All right, so again, what I want to look at is at half that linear term. So when I looked at the 8, I took half of 8, got 4, squared it, got 16, added that to both sides of my equation. Took my next linear piece with the y's, took half of the 6, squared it. Okay, half of 6 is 3, squared is 9. Added that to both sides. Okay. Now again, we'll deal with that negative piece in the next step. Okay, so now do number 4, rewrite this into perfect binomial squares. So pause. All right, so the x chunk, okay, you got rewritten as x minus 4 squared. Again, that 4 comes from half of the 8, and that's why some people say, hey, make it a negative, because half of negative 8 is that negative 4. Okay. Your y stuff, okay, half of the 6 is my 3, and then combining all the stuff on the right side. Now, one thing that can also help you out is if you would happen to get a negative on the right side, then you know you've done something incorrectly, because we can't have a radius squared be a negative value. Okay, so hopefully that's going to help you with circles. All right, with ellipses, we're going to attack it in a very similar fashion. I'm still going to put my x's together. So the 4x squared, the minus the 24x, the 25y squared, plus the 50y. So my y stuff's all together. My constant, the negative 39, move it over to the right side to make it a positive 39. Okay. The one thing that's going to change with my quadratic coefficient being 1, though, is if I just try to divide here by 4 and here by 4, I'm not going to get both of them to be 1. Okay. And that's because, again, A is not equal to C. A and C just have to have the same sign, so they both are positive or both negative. So in this situation with the ellipses, what we want to do is factor it out. Okay, so I'm going to take out that leading coefficient. So with the x's, I'm going to take out my a value. So I'm going to take out the 4. Okay. And then I have to remember to take it out of the 4x squared and the negative 24. Out of my y's, I'm going to take the c value. I'm going to take out 25. So it's very easy to see the common factor that we're going to have to pull out. And you know, more often than not, you're not going to see problems where your linear piece is not a multiple of what you're factoring out. Okay, so we shouldn't get like 40 divided by 25. But now I'm going to have y squared plus 2y. Okay. But notice again, quadratic coefficients are now both 1. Okay, that's what that step's all about. We're still going to go in and add half my linear coefficient. Okay. I'm still going to go in here and take half of 6 and square it. So half of 6 is 3, square it is 9. I'm still going to go in here and take half of 2, which is 1, and square it, which is also 1. But now I didn't just add 9 and didn't just add 1. Okay, if I think about multiplying this 4 back through, that's a 4x squared. There's a negative 24x. What actually is now part of this expression that wasn't there before is a positive 36. So what I actually did was I added 36 to both sides. Okay. So one of the things we have to do here is to remember to distribute. Okay. I didn't actually just multiply or add a 1 here. I actually added a 25 times 1. All right, so now, okay, after we've gotten that done, now it's the same as what we did with circles, so I'm going to write them as perfect binomial squares. The only difference here is that now I have a number out in front still, and we'll take care of that here in a second. But again, now it becomes x. And then that half there is that 3. And we got to deal with that minus. And then y plus half of 2, or 1, all squared. And over here on the right side, I get 100. Now, remember, with an ellipse, and that's going to be the step we're going to add in, our constant needs to be equal to 1. Okay, and the way we're going to deal with that is I could take 100 minus 99, but that's really not going to help us on the left side because all of a sudden I'll throw another constant there. What I'm going to do is I'm going to divide. Okay, so what I'm going to do is I'm going to come in here and divide 100 by itself to get 1. But then again, remember what your standard form looks like. You had a perfect square over some number squared. And so I have to remember to divide that 100 into every piece. The nice thing is these numbers out in front with the ones you're going to see should be a multiple of that denominator. If not, you've probably got to go back and look at what you did. So I'm going to divide a 4 out of the top and the bottom, which is going to leave me with a 25. I'm going to divide a 25 out of top and bottom, which is going to leave a 4 in your denominator. And there's your standard form. Now you'd be able to go and graph that ellipse. All right, so in the same way, what I want to do is have you do one on your own. So we'll go step by step, pausing the video along the way, writing down what we need to do. And so go ahead and do step number 1. And then pause it now, and then do step number 1. We'll come back and look at it. All right, so x stuff is all together, y stuff is all together, constant got moved to the other side. Again, remember to change your sign. Okay, so now go to step number 2, and again, remember what we're going to do there is we're going to factor. Okay, we're going to factor. All right, so for the x stuff, again, what we're going to factor out again is your value for a, which is 6. Remember to take the 6 out of the 24 as well. Out of your y stuff, you're going to factor out the c, so we factor out the 4. So again, take that out of 32. Okay, so now again, pause it. Jump on that step number 3, and then come. Okay, so what we did again here is I took half my 4, got 2, squared it, and got 4. But again, remember, distribute. 6 times 4. So I actually added 24 to both sides. Okay. Same way here. Half of 8, 4, square it, 16. But then again, don't forget we're distributing, so 4 times 16. That's where I'm getting that 64 that I truly added to each side. Okay. All right, so now jump on number 4. All right, so again, to get my perfect binomial squares, okay, half that linear is what's going in here with my variable. Half my linear is what's going in with my variable. And then what I'm doing again is adding all the stuff up on the right side. Okay, now do step number 5. And there you have it. Now, when I divided my 6 by my 24, you kind of can look at it as going from 24 divided by 6 gave me the 4, 24 divided by 4 gave me the 6. It should always end up with a 1 in front of your perfect squares in your standard form right now. And even if we don't, if it ends up being something there and that's a little more difficult than what we'll see, we would put that down into my denominator so it's all together. All right, I'm not going to get the other 2 in this video, so this will be entitled A, the next one will be B, or part 1 and part 2 to how we do ellipses, hyperbolas and parabolas. So hopefully this helps you out.